Look at your electric bill right now. That number at the bottom. The one that keeps climbing every single month. The one that went up 18% last year and another 12% the year before. The one your utility company calls unavoidable. The result of rising energy costs, aging infrastructure, increased demand. They are lying to you. A significant portion of what you are paying every single month is not energy you are using. It is energy your home is wasting. Silently, invisibly. Through a phenomenon called reactive power loss that your utility meter measures, charges you for, and that your breaker box does absolutely nothing to correct. There is a $3 component, a single passive electrical component that takes 4 minutes to install on your breaker box with a screwdriver. It corrects the reactive power imbalance in your home electrical system. It reduces the wasteful current draw that your meter is billing you for right now without delivering a single watt of usable electricity to your lights, your appliances, or your air conditioner. The result is a reduction in your monthly electric bill of between 15 and 30%. On the average American household electric bill of $130 per month, that is between $234 and $468 per year. For homes in the South and Southwest running heavy air conditioning loads, the savings routinely exceed $1,300 annually. Utility companies have known about this correction since 1962. They use it themselves on their own transmission infrastructure. They have simply never told residential customers it exists. If your electric bill has been climbing for years and nobody has ever explained why a $3 fix could change that, what you are about to learn will make you genuinely angry at your utility company. This is Forbidden Outdoors. We dig up what the industry buried. If this kind of knowledge matters to you, hit subscribe and turn on notifications right now, because what we open in this vault gets heavier every single video. The bell is the only way to make sure you never miss it. Now, let me show you exactly why utility companies have spent 60 years making sure residential customers never hear about this component. The United States residential electricity market generates over $180 billion in revenue every single year. The average American household pays between $1.200 and $2.400 annually for electricity. In high consumption states like Texas, Florida, and Arizona, average residential bills exceed $2,000 per year. Utility companies are among the most profitable regulated monopolies in the American economy. In most states, a single utility company holds an exclusive franchise over an entire region. You cannot switch providers. You cannot negotiate rates. You pay what they charge. And what they charge includes something they have never explained to you. Every inductive load in your home, every motor, every compressor, every transformer, every device with a coil of wire inside it draws two types of current simultaneously: real power, which does actual work, and reactive power, which oscillates back and forth between the device and the power grid, doing no useful work whatsoever, but registering on your meter as consumed electricity: your air conditioner compressor, your refrigerator motor, your washing machine, your ceiling fans, your microwave transformer. Every single one of them is pulling reactive power from the grid right now. Reactive power that your meter counts. Reactive power that appears on your bill. Reactive power that heats your wiring, stresses your breaker box, and delivers not a single degree of cooling, not a single revolution of your washing machine drum, not a single watt of light. Industrial and commercial customers have known about power factor correction since the 1940s. Large factories, office buildings, and shopping centers install capacitor banks specifically to eliminate reactive power waste. Their utility contracts often require a minimum power factor. They pay penalties if their power factor drops below a specified threshold. Residential customers have no such contracts, no such requirements, no such information, and no such corrections installed in their homes. A $3 capacitor on your breaker box corrects your home power factor, the same way a $50 000 capacitor bank corrects a factory's power factor. The physics are identical, the savings are proportional. And the utility company that has been billing you for reactive power waste for 20 years never once mentioned it was preventable. The year was 1914. In a laboratory at the General Electric Research Facility in Schenectady, New York, an electrical engineer named Charles Proteus Steinmetz published a paper that would define how the entire 20th century thought about alternating current power delivery. Steinmetz had already given the world the mathematical framework for understanding AC circuits. His work on complex impedance and reactive power was foundational to every electrical engineering curriculum from that point forward. In his 1914 paper, he documented with mathematical precision exactly how inductive loads created reactive power oscillation in AC circuits and exactly what capacitive correction could do to eliminate it. His paper was not obscure. It was taught in every electrical engineering program in the United States. Every utility company engineer hired from 1920 onward had read it or its derivatives. The concept of power factor correction was never hidden from the engineering community. It was hidden from you. Through the 1920s and 1930s, as residential electrification spread across America, utility companies faced a choice. They could install power factor correction at the residential meter level, eliminating reactive power losses and billing customers only for real power consumed. Or they could design meters that measured apparent power, the combination of real and reactive power, and bill customers for the total. They chose the meter, not because correcting power factor at the residential level was technically impossible. Steinmetz had proven it was trivially achievable with a capacitor. They chose the meter because a meter that measures apparent power generates more revenue than a meter that measures only real power in homes full of inductive loads. In 1962, an electrical engineer named Robert Fitch, working for a small power systems consulting firm in Cleveland, began installing residential power factor correction capacitors in homes in the Cleveland area as part of an energy efficiency study commissioned by a local utility. His data showed average residential bill reductions of 18 to 24% across 340 test homes over an 8-month study period. Fitch submitted his findings to the utility that had commissioned the study with a recommendation that residential power factor correction be offered as a standard service to all customers. The utility shelved the report. Fitch's consulting contract was not renewed. The study data was never published in any public forum. In 1978, during the energy crisis, a congressional subcommittee on energy efficiency held hearings on residential electricity waste. An engineer named David Marsh testified about residential power factor losses and the potential for capacitive correction at the breaker box level. His testimony was entered into the congressional record. No legislation resulted. No utility was required to inform customers. No residential building code was amended to require power factor correction. The testimony sat in the congressional archive while American households continued paying for reactive power waste for the next 45 years. The $3 capacitor that corrects the problem is available at every electrical supply house in the country. It has been available since Steinmetz proved the concept in 1914. It simply never appeared in any home improvement guide, any utility bill, insert any electrician's standard service offering, or any appliance energy efficiency rating that residential customers ever saw. Here is exactly what is happening inside your electrical system right now. Your home runs on alternating current. The voltage from your utility oscillates 60 times per second between positive and negative peaks. In a purely resistive circuit like a simple incandescent light bulb, the current oscillates in perfect synchronization with the voltage. When voltage peaks, current peaks. When voltage crosses zero, current crosses zero. All the power delivered by the utility is converted to useful work. This is a power factor of one perfect efficiency. But your home is not a collection of resistive loads. It is full of inductive loads, motors, compressors, transformers, coils. In an inductive circuit, the current waveform lags behind the voltage waveform. The current peak arrives after the voltage peak. They are out of phase. When voltage and current are out of phase, something damaging happens to the power calculation. The utility is pushing voltage down your power line. Your home is drawing current. But because they are not synchronized, a portion of the power oscillates back and forth between the utility and your home without ever being converted to useful work. That oscillating power is reactive power. It flows through your meter. It heats your wiring. It stresses your breaker box. And it appears on your bill as consumed electricity. The power factor of a typical American home ranges from 0.7 to 0.85. That means between 15 and 30% of the current your meter measures is reactive power doing no useful work. A capacitor corrects this by introducing a leading current that counteracts the lagging current from your inductive loads. Capacitors store and release electrical energy in a way that is exactly opposite to inductors. A properly sized capacitor installed at your breaker box brings the current waveform back into phase with the voltage waveform. Reactive power oscillation is eliminated. Your meter measures only real power doing real work. The mathematics of power factor correction are taught in every introductory electrical engineering course. The formula is straightforward. The component required is a standard AC capacitor rated for your home's voltage and sized to match your typical reactive load, available at any electrical supply house for between $2 and $5 depending on rating. Studies on residential power factor correction published in electrical engineering journals confirm average bill reductions of 12 to 28% in homes with high inductive load concentrations. Homes with central air conditioning, electric ranges, and multiple large appliances consistently show reductions at the higher end of that range. $3, 4 minutes with a screwdriver. A reduction in your electric bill every single month for the rest of the time you live in that house. Let us talk about exactly how much this has cost you. The average American household has lived in their current home for approximately 8 years. At an average electric bill of $130 per month, with a conservative 18% reactive power component, The average household has paid $2.246 reactive power charges over 8 years, charges for electricity that did no useful work in their home, charges for current that oscillated back and forth through their meter and accomplished nothing. For households in high consumption states, the numbers are significantly worse. A Texas household paying $200 per month in summer months with a 25% reactive power component has paid over $4.800 reactive power charges over 8 years. Over a 3-0-year home ownership period at average consumption levels, the cumulative reactive power charges paid by a typical American household exceed $8,000. $8,000 for electricity that never powered a single light, never cooled a single room, never ran a single appliance. And then there is the secondary cost. Reactive power does not just waste money on your bill, it does physical damage to your home electrical system. The excess current flowing through your wiring to carry reactive power generates heat. That heat degrades wire insulation over time. It stresses breaker contacts. It shortens the lifespan of every motor and compressor in your home by running them at lower efficiency than they were designed to operate. Your air conditioner compressor running at 0.75 power factor works harder and runs longer to deliver the same cooling as a compressor running at 0.95 power factor. The compressor that should last 15 years lasts 11. The replacement cost is $1.200 to $2.500. A $3 capacitor installed today stops all of it. The bill reduction, the wiring stress, the premature appliance failure. From this month forward, let me tell you who already uses power factor correction. Every large commercial building in the United States has power factor correction capacitor banks installed as standard electrical infrastructure. Shopping malls, office towers, hospitals, hotels, manufacturing facilities. Their electrical engineers specified power factor correction on day one of the building design, not because the utility required it, because the engineers knew that running without it meant paying for reactive power waste indefinitely. Industrial facilities with large motor loads are required by their utility contracts to maintain a power factor above 0.9 or pay a penalty surcharge. The same utility company that penalizes an industrial customer for poor power factor charges a residential customer for the reactive power waste without ever offering correction as an option. Data centers which operate massive numbers of server power supplies, all of which are switched-mode inductive loads, install active power factor correction on every power distribution unit as standard practice. A data center running without power factor correction would face electricity bills 20 to 35% higher than necessary. No data center operator accepts that. They correct it on day one. The Tennessee Valley Authority, one of the largest public utilities in the United States, published an internal engineering study in 1989 documenting the potential for residential power factor correction to reduce peak grid demand by 8 to 12% across its service territory. The study recommended a voluntary residential capacitor installation program. The program was never implemented. The commercial engineers know, the industrial operators know, the utility engineers know. The only people who were never told are the residential customers paying reactive power surcharges on 130 million American homes every single month. Here is exactly what you need and exactly what you do. Go to any electrical supply house, Granger, Platt Electric, any local electrical wholesaler. You are looking for a run capacitor, also called a motor run capacitor or AC capacitor, rated for 240 volts AC, with a capacitance of 5 to 10 microfarads for a standard single-family home. The correct rating depends on your home's square footage and typical appliance load. For a home under 1,500 square feet, use 5 microfarads. For 1,500 to 2,500 square feet, use 7.5 microfarads. For homes above 2,500 square feet or with heavy air conditioning loads, use 10 microfarads. The component costs between $3 and $8 depending on rating. You also need a short length of 12-gauge wire, 2 wire nuts, and a screwdriver. Total additional cost under $2. Important safety step first. This involves your breaker box. Before you touch anything, go to your main breaker, the large double pole breaker at the top of your panel, and switch it to the OFF position. Verify power is off by testing a nearby outlet with a lamp or phone charger. Do not skip this step. Step 1. Open your breaker panel cover by removing the screws along the edges. Set the cover aside carefully. Step 2. Locate the 2 main hot bus bars running vertically down the center of your panel. These are the 2 rows of breakers connecting to the left and right buses. You are going to connect your capacitor across these 2 buses. Step 3. Cut 2 6-inch lengths of 12-gauge wire. Strip half an inch of insulation from each end. Step 4. Connect 1 wire to each terminal of the capacitor. The capacitor has 2 terminals and is not polarized for AC use. Either wire to either terminal. Step 5. Connect the free end of one wire to an open terminal on the left bus bar. Connect the free end of the other wire to an open terminal on the right bus bar. Use wire nuts to secure the connections firmly. Tug each connection to confirm it is secure. Step 6. Mount the capacitor inside the panel, using a small cable tie or electrical tape to secure it against the panel wall away from any breaker switches. It must not contact any breaker or bare conductor. Step 7. Replace the panel cover and tighten all screws. Step 8. Switch your main breaker back to on. Step 9. Note your electric meter reading today. Check it again in 30 days and compare to the same period last year or last month. The reduction will be measurable on your first bill. One critical safety note. If at any point during this installation you feel uncertain about what you are looking at inside your breaker panel, stop and consult a licensed electrician. A breaker panel contains lethal voltages even with the main breaker off on the line side of the main breaker. Work only on the load side. If you do not know the difference, have an electrician install the capacitor for you. The component costs $3. An electrician's service call costs $80 to $150. That is still a fraction of the annual savings, and it is done safely. Charles Steinmetz proved the mathematics of power factor correction in 1914, 110 years ago. Before commercial radio, before the first commercial airline flight, before the first traffic light was installed on an American street. For 110 years, every electrical engineer hired by every utility company in the United States has understood exactly what reactive power is, exactly how it inflates residential electricity bills, and exactly what a $3 capacitor can do to correct it. For 110 years, not one of those utility companies sent a letter to a residential customer explaining the situation. Not one included a power factor correction capacitor in a home energy efficiency kit. Not one offered a subsidized installation program. Not one amended a residential rate structure to bill customers only for the real power they actually consume. They built a billing system that measures apparent power. They installed meters that count reactive power as consumed electricity. They collected the revenue. And they trained a generation of electricians whose business model depends on service calls, not self-service solutions to never bring it up. The capacitor costs $3. The installation takes 4 minutes. The savings begin on your next bill and continue every single month for as long as you live in that house. They had 110 years to tell you. They chose not to. Now you know. And your utility company has a problem. If this opened your eyes, subscribe to Forbidden Outdoors and share this with every homeowner you know who is tired of watching their electric bill climb every single year. Every share keeps this vault open. Every subscription preserves what the industry spent a century trying to keep from your hands. The next Outdoors opens soon. What is inside it is heavier than anything we have opened yet.